Hi, my name is Sir Arthur Eddington, and I was born in Kendal, England in 1882. After attending Einstein's reveal of his general relativity theory in 1915, I was told by my colleague Sir Frank Dyson of a solar eclipse expected to happen in May of 1919. That could be used to estimate the amount that light bends, which was relative to Einstein's theory. Dyson had hypothesized that using the eclipse to block the sun's light would make it possible for the light from the stars behind the sun, which could be observed without interference, and by comparing the actual location of these distant stars to the observed location, the first true measure could be made of high gravity effects on light. What were we trying to find? Well, I was trying to find valid measurements of the location of stars. This started by finding the true location in our everyday sky and then comparing them to the location seen during the solar eclipse through the sun's gravitational lens. By doing so, I was able to estimate the amount that light bends when passing a large mass that has a substantial gravity, which came to 1.75 arc seconds. This ultimately stayed closer in line with Einstein's theory that the relationship between space, time, mass, and gravity would cause the gravitational field by this large mass um, to bend the light when passing relatively close to this mass, which causes the appearance of the path to shift. In doing so, I showed that Einstein's theory was more accurate than that of Newton's. Where did this project or experiment occur? Since the 1919 solar eclipse was to travel overhead from Brazil to West Africa, over the Atlantic Ocean, and reveal the perfect positioning of the sun in front of the star cluster Hyades, I put together two expeditions, one to sail to Spanish Guinea in West Africa and the other to Sobral in Brazil. What other significant events were happening around the world at this time? During this time, the Treaty of Versailles was being signed, which brought World War I to an end. Who else was involved in the project? Though I was giving much of the credit for the observations seen because of the major contributions I had to the project, Sir Frank Dyson was the one that formulated the majority of the project, basically being the brains behind it all. Luckily, I also had a wonderful crew that was able to get clear observations of the eclipse, and was able to get us to those locations safely. What was your role in the project? I was the main physicist on the project and commanded one of the two ships that set sail on the expedition. As well, I undertook the responsibility of forming the two expeditions and gathering the supplies and resources that we needed to get to the two locations, to ensure the greatest likelihood of obtaining unobscured observations. What impact did your project have on the physics community? First off, the solar eclipse observations not only proved Einstein's theory, but also found that the sun deflects light up to 1.75 arc seconds. Today, physicists use this in many of my other observations of gravitational lensing to explain dark matter and the expansion of the universe. And lastly, how were you able to fund the two expeditions, especially since World War I was still being fought? Well, I submitted an application to the government grant committee, and the funding for the expedition was granted in the amount of £100 for instruments and £1,000 for travel and other expenses. The war did bring up my status as a conscientious objector, which was frowned upon at this time, as well as the argument was made that money should not be taken away from the war effort, especially for scientific discovery. After much arguing on Dyson's part, there was a compromise stating that my draft could be postponed with the conditions that the war be over by May of 1919 so I could go on the expedition. as well as that I lead the expedition.